Okay, welcome everybody. I'm really pleased to be joined by Jason Ness and Stacey Connolly, as well as Christy Thomas, and we're going to take a look at scaffolding numeracy skills across the curriculum. Thanks for joining us today, guys. I really appreciate it.
You're welcome.
Thanks for having us.
Yeah, glad to be here.
As you can see, we've got this joint collaboration today between Rockview Schools and Ambrose School of Education. And the intended audience of this is both in-service teachers and pre-service teachers. We want to chat a little bit about how we're thinking about designing numeracy, and hopefully that gives you a way to think about your own practice. We've got a few conversations built in, and mostly we want to take a tour through our numeracy practice across the curriculum. Let's start with a quote from Stacey. Stacey, I grabbed this off of one of your blogs that you had written where you were talking about the difference between math and numeracy, and that you normally get that question. Can you help us think a little bit about the distinctions between math and numeracy?
Yeah, I think with numeracy, we hear that word number built right in it, and we just automatically, our brains go towards math class. And I think when we are talking about numeracy, it's actually so much more, right? In Alberta Ed's definition, they talk about the ability to reason quantitatively and numerically, and to think about and being able to apply those skills in other situations. So to be numerate means to have the confidence and skill to use numbers and mathematical approaches in everyday life. So that means when we're at home, when we're cooking, through our jobs, even driving our car, it helps us make informed decisions. And we do math in school to help us become numerate, but numeracy also lives in many different school subjects, in all different school subjects, but also it transcends school. It helps us make sense of the world around us. It helps us make decisions as adults and with our students as children in their day-to-day lives.
Just a little bit important, I guess.
A little bit, yeah.
Especially in today's world. And that's kind of what I wanted to transition to. So super important. Everybody needs it. Drives a lot of our life. We can think about that in our budgeting and the way we vote. And but how do we think about teaching it? Why this focus on numeracy, and how do we begin to think about how it lives in the classroom? Jason, can you help us with that a little bit?
Yeah, I think it is a bit of a complex question, but ultimately it boils down to creating a mindset that surrounds number and space and shape. And as your graphic shows here, that it definitely is about knowing some of what the discipline of mathematics has to say about understanding number, understanding relationships and patterns and space and shape, but it also is contextually driven. So it's not just that we know how to add, subtract, multiply, and divide. It's that when we're teaching numeracy, it's about building up a student's mindset around where and when do those things apply within a particular context. And then I think most importantly, it's you hear the phrase, well, I'm not a math person, or, oh yeah, I am a math person. And the goal, one of the main goals of teaching mathematics, teaching numeracy, is to really help students develop a confidence and a growth mindset about what it means to be a mathematician, for lack of a better word. But it's obviously it's much more involved than just math. It really is about a way of approaching the world that allows you to use number and use math in a way that's useful to you, and that you feel confident and comfortable with it.
So we have this graphic that comes from your work in Rockview Schools, your balanced numeracy framework. And I've kind of got at the top of this slide, like, first of all, what does teaching numeracy look like in mathematics class? Because what I heard you say, think about this idea that there's a lot of people out in our world that don't think they're math people. And yet they're voting and they're baking and they're taking a mortgage, and so they are numerate, or at least they're needing to be numerate, And if they've got an aversion to math, those things don't work well. And maybe that's why we have, so many payday loan stores and all sorts of problems when we think about applying mathematics skills. So obviously, math class needs a transformation, at least from the way that what resulted in a society of many people that are fearful of math. What does it look like to think about numeracy in math class?
So this graphic comes from our Rocky View numeracy framework, and it talks about, as our goal, as Josh just explained, is for all of our students to be numerate. And when we do that, we have to think about, that's our why, that's our purpose, that's the thing we're after. We want our students to become numerate. So in math class, we think about being intentional about how we go about that. So we want our students to be fluent, meaning we want them to have those mathematical skills that we teach in math class. But fluency is more than just, being able to do the math. It's about being able to understand the math. So sometimes when we're designing math in our math classes, we're still thinking about, developing those skills, but also that understanding through building fluency. We want our students to reason, right? We need to give our kids opportunities in math to reason, to justify, prove, investigate, test, make conjectures and generalizations, that critical thinking piece that helps our kids really deepen their understanding. Because that's what we do, right? When we are building a fence in our backyard when we're adults, well, we have to do a lot of reasoning there. We have to make we have to do some investigating and testing, and we have to take those skills and apply them to a new situation. And that becomes our reasoning and helping us make informed decisions. Problem solving is another key component. If I had to boil numeracy down to one thing, it is problem solving, right? We're problem solving every day, all the time, numerically in our life. Do I have enough gas to make it to work? Do I have enough ingredients to make this recipe? Those are real problems, and they're where we want to get our students. Often when we think about math class, we do a lot of time building around fluency. We spend a lot of time building those skills, but do we spend equal amount of time giving those problems that make our students develop those problem solving, perseverance skills to help them do that? So what we want to do is be intentional, right? What are we trying to get at in math class? Are we just building skills for today? And sometimes that's all right. We need kids to practice, right? We want to practice their skills. Do we want them to think deeper? Is the opportunity for them to reason their way out of an open task or an open problem? And am I choosing a resource that is focusing on giving them opportunity to communicate and explain and justify and prove their decisions? Or today, I want them to take their skills and apply it to a problem. And when we say problems, we mean real problems, not word problems where it's a contextual, but the answer is contrived, but problems where there's no clear path to the solution and kids have to make their own decisions. So the outside circle here really says intentional learning experiences. Are we intending to choose activities or tasks that are building fluency, which are skills, reasoning, which is that critical thinking, or problem solving? So my first advice for any teacher when they're designing math in their class is when they're taking a task and looking at it, what are we trying to build? What are we looking for? And will this activity or this experience I've created, what aspect are we building? Fluency, reasoning, or problem solving?
Now, Christy, you had a question earlier when we were chatting about resources. Do you want to maybe frame that now?
Sure. A lot of our students, when they go out into field, they have different experiences with resources, and obviously there's a lot of programs to draw on. What advice do you have for students as they think about building their own numeracy program in terms of moving forward and being a first year teacher? What does that look like, and how do you make those decisions about those resources? Are you relying on just one, or are you pulling from a number of them, and how does that fit in with this sort of kind of goal in terms of bringing numeracy into the classroom?
That's a great question. And, obviously there are a lot of resources out there. And I think one of the most common ways when someone hears the word resource, they immediately in their minds jump to the idea of the textbook. What's the book that I'm going to use to teach the math? And I think as you're stepping into a classroom, perhaps for the first time, there's going to be probably a high degree of dependence on some of those resources, whether the resource is in fact the textbook or a particular piece of software, or really just even the binder of the teacher in the classroom next door to you. And I think the first thing is for that to be okay, particularly early on, that a lot of the resources that are available to us we're going to need, because there's only so much time and energy you have to put into creating your own. But I think it's really critical to move as quickly as you can from this sort of resource dependent state into at least a resource discriminant state. So one where you can look at a resource and say, okay, this is a useful tool for helping to build some fluency. So I can give my students some procedural questions that will allow them to learn a skill, maybe even habituate a skill, though to be honest, as a numeracy specialist, my goal isn't to have students remember how to do a particular skill, long divide or whatever it is, but rather to be flexible in their understanding. So as Stacy said earlier, fluency is a lot more than just knowing how to apply the algorithm. So your resources, it's important for you to know how is their resource related to this idea. What does it build? Stacy just said a moment ago that know what your resource is for. So there are some resources out there that only do fluency, and being aware of that, and then determining how you're going to design an experience for your students that's going to allow them to reason and problem solve as well is really important. And I think the one way that we often look at as sort of the beginning point in that progression is taking that closed-ended question in your textbook, what is 7 plus 3, where there's only one right answer, and opening it. So how might we create or design a task where there isn't necessarily a single right answer, and there might be more than one way to arrive at an answer. It might be as simple as what numbers could add up to 10? And that all of a sudden opens the question. Or how might we make 10 mathematically? So something like that will allow us to progress sort of around that wheel.
Thanks. I think that's really helpful, especially thinking about this idea of shifting. We also were talking previously, Josh and I, about this piece about numeracy across the curriculum. And we know that research kind of shows that students just don't automatically make those transfers to other learning environments or other subject areas. And so can you guys talk a little bit about how students can learn to introduce and integrate numeracy across the curriculum? How might they do that? Why is that important for our students?
As you said, Christy, it's not something our students do naturally, and they build that ability to take what they learn in one discipline and apply it to a new situation. How do we do that? And what we need to do is be really intentional about this, right? We need to be able to see the intersections, especially in elementary education, in between what we're doing in language arts, what we're doing in math class, what we're doing in science and social and everything else in between, and find out where those natural intersections lie. And I think where we start as teachers to do this is by tearing those curriculums apart and finding where those natural connections lie. Instead of the other way around, because sometimes what we hear about is, oh, we need to do numeracy in this discipline, so I am putting the numeracy into it. And I think for me, that is absolutely the opposite of what we are trying to do. We're trying to find out where numeracy naturally lies within that discipline. In our math curriculum, in all grades, we have some outcomes that naturally lie in all different disciplines naturally. So for example, data, measurement, probability, those are like shape and space. Those outcomes naturally have connections in our social studies or in our science. And being able to go, hey, so we are learning about systems of government. What are those outcomes that I need to get through in math this year that might help me get at that concept? So is it our data handling outcomes that we can then to make those connections? As a teacher, this is a great activity at the beginning of the year to really look and tear your curriculum apart and go, what is it in math I really need to focus on? We still need to build those skills, reasoning and problem solving. But where is there time, and how can I focus, take some of those outcomes out of math class and make connections? That doesn't mean that you still might not come back to them in math. You still, need to really examine the concept that you're learning. But if I'm doing plant growth and change in grade 4, there's a lot of opportunity for measurement and data collection there, and being able to go, I can make those connections so that I don't have to all the time spend this time in math, but I can focus a little bit of my time in science to show, hey, here's how we measure, and here's how we do a bar chart. And then so that when we come back to math class, the students have a real opportunity to understand why that they're learning that. And we can talk about transfer, right? So there's times where you're going to focus on, hey, and here's the x-axis and here's the y-axis, and we're going to spend time building our bar chart. But now you're going to go and do it in science. Sometimes you'll do that in math earlier in the day, and then later in the afternoon you'll do it in science. And other times you're going to say, right, we need to build a bar chart right now. This is our science lesson. We're going to do it right now. And then go, oh, by the way, we just did math too. It offers us a lot of opportunity for assessment. We can continually be looking for evidence of understanding through our conversations, observations, and products throughout all different subject areas. But first we have to be intentional, right? Are we intending to highlight that math outcome or that numeracy idea in what we're doing? Because often sometimes we don't highlight them and they just get missed out completely.
Yeah, I think that's really helpful and practical. Thanks for sharing. Just even the design of going into the curriculum initially at the beginning of the year and looking at it, pulling it apart, and being really aware of what those outcomes are, so that we're not just, it's not a force fit. I appreciate you sharing that process. I think that's helpful.
Now, Alberta Ed has some resources that can help us with that process, right? I think we're going to talk a little bit about the numeracy progressions and how they sit in us thinking about where to build numeracy into different curriculums. Can you talk a little bit about that resource?
Yeah, this is a really useful piece, and there's a lot to unpack in that diagram. So, I wouldn't say try to digest it all at once, but it's really this idea that there are some fundamental big ideas in math, and our curricula weave those big ideas in a progression throughout all of the math curricula from from kindergarten all the way to grade 12. And so it's useful to understand, within a particular big idea, let's just say additive thinking. What does that look like as you go across the grades? How are we expecting students to grow as an additive thinker? Having that awareness of where they ought to have come from it allows you to pre-assess well. It allows you to evaluate students' skills and knowledge as they come into your class. And it also gives you a sense of what's going to be important as they build those skills and move beyond your class. So there's definitely some rich information in there. Not only do we want to consider within mathematical big ideas, so additive thinking, multiplicative thinking, shape and space, but we also want to think about those key processes, those 7 processes that you see in the math curricula, such as mental math and estimation. How are we finding ways to have students estimate across the disciplines? So, are we estimating, area on a map? Are we mentally, doing some processes to understand the projection of what's going to happen in our plant growth, those sorts of things. So this is a very deep image, along with a document that goes with it. And I won't get into all of it, but knowing how numeracy is built within the discipline of math and within the other disciplines of school can really help you do those create those intentional experiences for students and give them opportunities to reflect in a way that makes it very visible to you as the instructor, as the educator, so that you can assess them meaningfully, both formatively and summatively, in terms of the growth along that progression.
I just want to add there that top of the circle, the green bit, which is numeracy awareness. And I think we talked about teachers being aware, but it's also really important to ask students what numeracy, what math is in this science task, right? And getting them that to build that awareness of when they are using those numeracy skills. So they have, we want kids to value the importance of numeracy, the learner awareness being, hey, oh, guess what? I'm in science, but I am doing math. And then task awareness. Hey, what math do I need to do to get this problem solved?
And I'd imagine that might even help with that sort of confidence or like belief in themselves as a math person or interest in math. If we start breaking down those subject barriers, because all of a sudden I might not be a math person, but I love science. And now that I see that I'm doing math in science, or I'm doing math in social studies, and it's helping me be, I'm building on the strength that I have in some of those other subject areas, or the interests that I have in that other subject area, and realizing the way in which I'm using math towards something that's interesting me, and it can contribute to something that I'm interested in. I hope that, as we, shift the way we think about, give students ways to think about themselves as a math person, that'll have an impact on that whole identity that we were talking about earlier. Okay, so math is in science class. We keep talking about math being everywhere, but I have encountered lots of people who feel like they need to look a little deeper to see that right away. We can say, well, this chair I'm sitting on has a lot of math built in, but seeing that math sometimes takes another way to start looking at things. So I thought maybe we'd take a tour through some of the other sort of subject areas and just have, in general terms, get you guys to brainstorm a little bit about where you see really good fits for math. And then later we're going to pause the video and have some opportunity for students to dig a little deeper with thinking about using the numeracy progressions and brainstorm a little bit about where they might see a fit. But Jason, I know you taught high school science. Christy, so did you. When you think about that discipline, where's the math in it?
Data obviously jumps straight out. So both in the collection of data and in the communication of data, and the interpretation and the analysis of data. So, we start very early on in the science curriculum with students, gathering information about the world around them, making conjecture, testing hypotheses, and problem solving being a fundamental component of numeracy. Science is ultimately the ultimate problem solving discipline. What are the interesting problems that exist in the world, and how can we go about finding answers to them? And to do that, we gather data, we represent data, we analyze and interpret it, not necessarily in that order, but as well, like some of those time outcomes in the earlier grades as well speak directly to circadian rhythms and seasons and positions of moon and sun and space. And then that starts to lead into our space and shape outcomes in math. So how does geometry fit with our understanding of the physical world? When we start to look at space exploration, what does it mean to look at ellipses and the role of gravity and all of those types of things for which we do number? Obviously later on when they get into high school, they're going to be doing direct calculations in chemistry and biology and physics, but those start off very early on in our science curricula. And there are pieces in science in our programs of studies that directly call out where some of those numeracy connections can be made.
So when you do this thinking, you're looking at what you're needing to do in science, what your outcomes and big ideas are, and then right at that stage of the design process, you start to ask yourself, what numeracy skills are students needing to apply in this context? What is the scaffolding that's required for them to be successful in science? And then that's where you can pull in your math skills and resources and start thinking about those interconnection points. Is that your design process when you think about it?
Yeah, I think in the early going of a design, whether it be a lesson, a unit, even the arc of learning that might span, a year or multiple learning outcomes. I think starting with the end in mind. So having an understanding of where you want to take the students, and right early on, if you haven't done the work of sort of teasing apart those curricula, plural, that gets a little more difficult. So if you don't have an awareness of what your data outcomes are, because you've mentally just, oh, data is a good thing to do in June, as you're starting to figure out what the science how you're going to meet your science outcomes, you're already, I wouldn't say you're in trouble, but it's going to be hard to weave those together. So you'll have had to have unpacked all of your curricula. And then as you're thinking about the experiences that you want to have, you want your kids to have, and how they're going to reflect on those experiences, in that design, you're immediately starting to make those connections. So it might look like, let's just say that we're starting from a science perspective. And Stacy said earlier that we don't want to try to force fit the numeracy in, but if you have an awareness of what the data or the time outcomes already look like, as you start to look at those science curricula, you're starting to think about, okay, what experience do I want my kids to have as they're starting to explore weather? How am I going to want them to reflect on those weather outcomes? And as they're doing that, is there a component of the numeracy curriculum that fits right in that reflection? Are they going to have to count? Are they going to have to measure? Are they going to have to consider spatial relationships? Are they going to have to represent data? So as soon as you're in that mode of what is it that you're going to have your students do, you start to think about, okay, that fits with this outcome, and I want to be intentionally designing those experiences and reflections such that they're going to meet some of those outcomes, and I can formatively and summatively assess them right then and there without having to like pull them out and jamming them in math class. You might go back to them in math class because there might be some conceptual mathematical understanding that comes with that. It's not to say that you pull it out completely, but seeing where those connections can be made by having awareness of your curricula as you're starting your design process is really important.
Let's give them a chance to try that right now. I'm going to pulled a couple of different big ideas from the numeracy progressions that we introduced earlier that you see in the table below, and it just kind of shows how it articulates up from kindergarten right through to grade 12, and also pulled sort of some science graphics, just get you to think, okay, organization of data, collection of data, interpretation of data. We're going to give you a moment here to be in a breakout room and have a conversation about where you see some opportunities for these things to occur within the context of science. And there's already been a few hints. Plant growth and change, I know, came up earlier, and a whole bunch of other examples, but we'll give you some time to have a conversation and then come back and share it with the larger group. Okay, so you got me, Stacy, Jason. I buy it. There's lots of numeracy in science class, but it feels like more of a stretch now in the gym. Like, where's numeracy opportunities in health and physical education? Anything come to mind right away for you guys?
First, I think we have some general phys ed outcomes and health outcomes that mention numeracy right in them. We can think about calories in our food. We can think about measuring distance and shape and space. We can think about time. We can think about heart rate. I'm looking at these little icons. They've given me all the clues I need right here. There's so many things that we can do and make explicit connections with our health and phys ed class outcomes. But what I really like about these ones is they're fun. People like to talk about them. They make the math come alive because they can see real connections to themselves. And I think, we've seen great projects where people have done mini Olympics and then all the math that's involved in doing those pieces. But when it really comes down to it, it's that picture in the middle. It's about yourself, and you're thinking about what are the numbers like in my life, right? What is it what, my calories I'm consuming, the exercise, my heart rate, the amount of time I'm spending. Those things are naturally in phys ed. And I think sometimes we gloss over them so quickly when we could spend a lot of time really digging into those in phys ed, but also in math class, right? So we could be doing our work in the gym and then bringing back our data and really digging into it deeply in math and making those connections the other way around as well. Not putting the math into phys ed, but taking the phys ed and putting it into math.
Yeah, and I think right away about the motivation that a lot of students have when they're thinking about physical education and how that can connect for a lot of them with math, and how often we apply numeracy in our lives in relation to our health and well-being as well as physical education. I'll stop pretending to be surprised about the connections. What about language arts?
I love this one because I think if there was any discipline where, okay, this is the furthest away from numeracy, this is probably it, even more so than I'd say art, which is another one that folks are like, I don't quite see where it fits in. Language arts, we often think language arts is being about narrative, about story. And there's plenty of places where story can live in math. We talked about those problem solving approaches. Not every problem that needs to be solved has a number attached to it. And you'd be surprised how many puzzles and riddles do really build some of those numeracy skills without actually having to put a digit in there. But we also see that within number, there's great stories that can be told. In fact, we have teachers right now who are taking the idea of the readers and writers workshop, and okay, what's that going to look like if we did math workshop? So what is the tale that can be told with the materials that we're using to represent number? What is the tale that can be told, whether it be fiction or nonfiction, about how it is that we're coming to understand the world around us? So what are the stories? What are the stories of the world around us that include number? So, and what that does is it makes those direct connections between my life and the things that excite me and interest me, and allow the numbers to not feel like they're completely separated from those things. So, story.
Well, when I heard you talking about story, I also thought about the ways in which data tells a story, and then how we use that story to communicate and persuade others. So there's like this synergy. I feel like scientists, for example, communicate a story with numbers alongside text. So there's this sort of I start knowing which one is which. Like, am I communicating effectively and persuading an audience and crafting a message to respond? That all sounds language arts. Yet what happens when I'm doing that with data, right? And what happens when I'm doing that with graphic representations of data? I feel like we can really start to, because language arts is all about communicating, as you said, and all about a story and all about using language. We can really think about the interconnectedness. Like I say, I can hardly sometimes think where one stops and the other one starts. Am I doing language arts now, or am I actually doing numeracy or science?
And even if you think about it, that just reminded me of not just when you're talking about language as understanding and interpretation when we're reading, and comprehension, and when we look at maybe not a narrative text, but we're actually reading like a news report, and we have to interpret the data, we have to make sense and meaning out of it too. And so I think data is, I agree with you, that piece, that interplay of data and text, and how that brings us a way to see numeracy and language arts as well.
Fine arts class. What do we think? Where's the fits here?
This is another one where I think that we should take the art and put it into math class, because I think that there are so many of our outcomes in all grades that we could use to represent mathematical understanding through art. We had some teachers the other day, they were in grade 7, they were exploring circumference. of circles and the art that their kids are going to be working on around, you know, just drawing circles and using the math and applying there is really, it's amazing. And kids are getting a deeper understanding because they have a different way of representing. There is math in all of the fine arts we talk about, right? We can talk about drama and timing. We can think about music, and music is the one where I'm just like, there are so many connections. And you know, studies can show us that kids who are musical are actually very mathematical. As we know, music, there's lots of fractions, there's times, there's all of these pieces, and we don't necessarily draw attention to it, but we should, right? Because we have kids who love the arts and who are engaged in art, who might not necessarily see themselves as math people, but as teachers, if we spend some time highlighting for our students where the math is in the things that kids love and enjoy doing and why it's important in those areas, I think we will build more numerate students.
I'll just add as well, a lot of the tools that we're using in art, particularly the graphic arts, are the digital tools we're using are highly mathematical, and having a sense of what it means to transform an Illustrator diagram. And even young kids can access these things. Not only do we see space and shape built right into the tools that we're using, but we're actually also seeing concepts of number in transformations in vector diagrams. So there's some great opportunities to take a lot of those tech tools that we're using and look at how number fits right in those tools and what it can produce in our art.
Social studies. This is one that sometimes gets paired with language arts, right? We're like, oh, we have the humanities, then we have math, science. But I think there's a lot of opportunity to think interdisciplinary within social studies. What jumps to mind for you guys?
I think the first thing is data. I think there's so much data. And in fact, I don't think we can do social studies without looking at data of some kind, right? From early on, where we look at data collection and data analysis as part of social studies. Josh, you mentioned earlier about, you know, making decisions and voting and all of these pieces and the importance that has. You know, measurement, we do a lot of map work, we do, you know, spatial reasoning, all of those pieces. I see these two as really interconnected, and I think it's about interpretation again, right? And interpreting situations in social studies, and without that, the math is really hard, right? Or without that, the subject, without being able to interpret, the subject becomes really hard, and you're going to need the math to help you interpret. I think, you know, some of these connections are really obvious, but again, it's about highlighting and drawing attention to, and scaffolding for. So students who are struggling in areas of numeracy will need some scaffolding to interpret the data in their social studies class. So we have to think and be intentional about that. They might have a very deep understanding of the concept, but accessing how to read a bar chart, and this is a very basic example, but how to read a bar chart is challenging for them. So we have to be aware that in the same way we are about literacy, that there is some scaffolding in other disciplines around numeracy that needs to take place in order for all students to be successful.
I love that you brought that frame forward, because sometimes all this could seem sort of like extension stuff, right? It could seem like, well, this is how we could go above and beyond looking at the discipline, but you're also framing that this is essential to access some of the conversations as well. So it's both providing opportunities for all students to learn, supported by that scaffolding that numeracy offers.
Well, and even just thinking about too, that sometimes there's that excuse that, oh, that's being done in math class, right? And I don't need to worry about it when I'm doing social studies. So I think you brought up a really, again, making those connections and putting that scaffolding in is really helpful for students to see that's a responsibility across all the disciplines.
Yeah, and if we don't do that thinking in connections, again, back to our original, you know, slide about what is numeracy, how will students apply it? But it's within the realm of social studies and society. Often we were talking about the importance of students having these skills. So yeah, building that explicitly. Here's a chance for students to think through that. And again, we're going to pause the video and give you a moment to brainstorm possibilities, particularly with these three streams of big ideas: magnitude, probability, and time, and just thinking about your awareness of social studies and where you see some really good fits. We'll pause and get you to do some thinking together and come back to the large group. Okay, this one, we've been maybe drinking from a water hose a little bit. We're talking about first year teachers, well, not even, just coming out of our first practicum. We've probably given some advice, but if you're going to distill it, where do we get started thinking about our responsibility as numeracy teachers?
Digest your program of studies. I think that's the number one. Know your curriculum, and don't just figure out the sequence and hit it when you get to it. Take your time to be really intentional to understand what's the breadth that you need to do. Have a sense of, you don't necessarily need to read it all, but a sense of where your students are coming from, so that you've got some pre-assessment opportunity. You can sort of see what they're walking in the door with before you start to tackle big ideas. Look at those places where they naturally fit. And I think a really, really important one is consider the themes of your program that you're going to keep revisiting over and over and over throughout the year. You don't just do a multiplication unit. Multiplication is an idea that you revisit continuously over and over and over again. So it isn't necessarily something I do in November and then my multiplication is done, but rather it's an idea. And we're going to spend the year really working on developing some of those skills that transcend many of your units. So that's my thought. Stace, do you have another?
I think I'll just reinforce the idea of intentionality. Like, just be intentional. If it comes to, oh, I think I should do something interdisciplinary and I need to put numeracy in it, that's kind of a no-go for me. I'm kind of like, just stop, because the numeracy should already be there, and it's just bringing it out and highlighting it rather than trying to force it in. So take risks, try it. It's good. Sometimes it's messy. It will always be messy. There's everything in teaching always has an element of messiness, but just being intentional and finding out, where numeracy naturally lies, and then going with it and building upon those opportunities for students to transfer the math that they're learning in math class into other areas, but also how to transfer into math class as well. Right? So making those real connections that are going to build that awareness about what numeracy is.
And I think this is really a practice, right? That one has to be intentional, again, about getting started with. Like, start having these conversations about where numeracy lives with your partner teacher, with your colleagues. Take PL opportunities. I think this is one of these big bucket things that as an elementary teacher, we need to see ourselves as a numeracy teacher, and I think we need to see this as one of our foremost responsibilities, and seeing that as something that we take on as a learning journey. So we hope this video gave you some places to start. Christy and I are going to keep unpacking it in our class and get you to do some application for those of you that are watching this from CDPD 600. Huge thanks to Jason and Stacy for joining us today and sharing your wisdom and insight. We're so dependent on your resources to help us with our students, and we really appreciate how you make your learning visible and put it out there for the world. And we hope we get a few future RBS teachers coming your way that have a bit of a head start on how to think and work as a numeracy teacher across the curriculum.
Thank you very much for joining us today.
You're welcome. All the very best to your students in their future endeavors.
Yeah, thank you.